Algebra 1 lessons 23 and 24. Going to be a quick overview of these two lessons. Both of them are solving two-step equations. The first one is with whole numbers and fractions. Second one is with decimals. So remember, when we are going through two-step equations, we need to use inverse operations. So addition and subtraction are inverses, multiplication and division are inverses. But we must undo the addition and subtraction first. Okay, we shouldn't undo the multiplication and division and then try to add or subtract. Remember, we want to do PEMDAS backwards when we're undoing things with an equation. So to look at a few examples, 3x minus 2 equals 10. Well, if I need to do the addition and subtraction first to get x alone, that means that I need to get rid of this minus 2. So to get rid of a subtraction, I need to add 2 to each side, so that I get 3x equals 12. Well, now we just have a one-step equation with multiplication, so to undo that, I use division. And I get x is equal to 4. Remember, you can always check by plugging it back in. Let's try it with the other one. Once again, we have to do that subtraction first. We have to undo that, so we need to add 15 to each side. So we get 27 is equal to x divided by 9. It may be really tempting to be like, okay, 9 and 27 are related, so maybe x is 3. But that wouldn't make sense here because 3 divided by 9 does not equal 27. So we must do the opposite of division, which is multiplication. So 27 times 9. We get x is equal to, well, 27 times 9. We get 63, 18, 243. Which we could say 243 divided by 9 minus 15 does give me 12. Okay, let's just go through a couple more examples of this. Remember, with this one, we can subtract 5, which gives us 12 on each side, or 12 on the right side. So we get 4x equals 12, divide by 4, and x equals 3. It makes it really nice to go down like this, have your equal signs staying in a row, and doing to each side the same thing. All right, so let's try another one. Negative 10 minus r equals negative 20. Well, this negative 10 is a subtraction, so I need to add to get rid of it, which means I am left with a negative r equals negative 10. Well, I can't just leave it like that because r is still not alone. Technically, I have a little negative 1 times r. So to get rid of it, I'm going to divide by negative 1. And a negative 10 divided by a negative 1 is a positive 10, which makes sense because if we plug it in, we would say negative 10 minus 10 gives me negative 20. Okay, let's do this one with some fractions. We're going to go through the same steps. We're going to add 1/3 plus 1/3. Well, unfortunately, these don't have the same common denominator. So I would say 3/4 is the same as, and 1/3 is the same as, well, we need a common denominator of 12. So we would say this is 9/12 and this is 4/12. So if we add them together, I get 13/12 equaling 1/2 n. Well, I could just divide each side by half, or I can notice that if I multiply by the reciprocal, that would work too, because that is the same as dividing by a fraction. So I can simplify and get 13/6. Okay, n is 13/6. So this process works for our fractions as well. Looking at some word problems, a gym charges a $90 fee plus $30 per month. Another gym charges a $1,500 unlimited fee. Okay, how many years will it take for the charges at the first gym to reach $1,500? Well, if the first gym is $90 fee plus $30 per month, and I want that to eventually equal $1,500, I have just set up my equation, which I can then subtract 90 and get 30m equaling 1410. If I divide by 30, I get m equals, I believe, 47, which means it's going to be 47 months or 3 years and 11 months until we have the same price. And again, Perfect Painters charges $25 for paint and $25 per hour. A different painting company charges just $2.50 for the whole job. How many hours will it take for the Perfect Painters to charge the same as Classic Painters? So we set up our equation. 25 for the paint plus 25 per hour, and we want that to eventually equal $2.50, the other company. So we subtract 25, and we get 25 hours equals 225. We divide by 25 on each side, and we see that it would take 9 hours for them to be the same price. So if it was less than 9 hours, more than 9 hours, think about which one you would choose to be the least amount of money. Okay? Thinking about our decimals for lesson 24, we can go through these steps. Now, these steps will always work for multi-step equations, two-step, with decimals, with whole numbers, fractions, but we need to combine like terms on the same side. Okay, move variables to the same side. So let's say we start off with something like 2x plus 3, x plus 3 equals 5x. Well, or let's make that 15x. I'm going to combine like terms on the same side, so we get 5x plus 3 equals 15x, and I want to get the variables on the same side, so I'm going to get them on the right side. And so I'm going to subtract 5x, so that I get 3 is equal to 10x. Then it says solve for the variable. So in this case, I would just divide by 10 and see that x is 3/10. So combine like terms, move variables to one side, move constants to the other, and solve for the variable. So let's practice with some decimals. Same idea as before. I'm going to look at what I need to add or subtract first to get rid of things. And this 8 has been added, so I'm going to take away 8. And so that I get 0.5x equals 2.5. I divide by 0.5 on each side, and I see that x is equal to, well, let's do it because it's really easy to mess up with decimals. So 0.5, we're going to move those decimals, and I get just 5. Okay? Let's do it again with the next one. I have added something, so I'm going to subtract it. So I get 0.006a is equal to 0.18. And I divide by 0.006 on each side. Which means that if I actually divide it, okay, 0.18 divided by 0.006, I have to move that decimal 3 times. Easy to mistake this as maybe an answer of 3 because it looks like it, but we see my answer is actually 30. A equals 30. Let's just do a couple more examples. You can do that one on your own. Okay. So for this one right here, let me just fix that really quick. And we can see that on that left side, we have subtracted a 1.2. So to undo that, I need to add a 1.2. Okay, add 1.2 on each side so that we get negative 0.03n is equal to 2.64. And I divide by a negative 0.03 on each side. Remember, this is a negative 0.03. So that I will get an n equaling, well, we know it's going to be a negative, and let's work it out. 2.64 divided by 0.03, we'll add the negative we did in our answer, move it twice, and we see, okay, 3 into 26, that can happen 6 times, or sorry, not 6 times, 8 times, good grief, 8 times, and we get 24, so we have another 4 coming down, which means another 8, all right, That will work it out, and we have a negative 88 as my answer. Okay. All right. If you do this one, 0.48 of 86 is what number? We just need to multiply these together, so you can try that on your own. Last example for now. The height of an average mandrill, a large species of baboon, is 2.54 centimeters more than 12 times the height of its tail. Okay, so let's put that into an equation already. 2.54 more, that means addition, than 12 times the height of its tail. I'm going to represent that with a T. If the height of a mandrill is 78.74 centimeters, then what was the length of its tail? Well, this 2.54 plus 12t, that tells me the height. And so if we have one that's 78.74, I can solve my equation. I'll subtract 2.54, which means that I get 76.2 equaling 12t. And when I divide by 12, you should get t is equal to 6.35 centimeters. So its tail is 6.35 centimeters long. Well, I hope this was helpful for your homework and for studying.